We've been watching Greenland melt for 25 or 30 years now, and you can see the surface melt every year from satellite data. We know the weather pretty well. We know when it gets warm enough to melt the ice. But looking at the glaciers around the edges, these fast-moving rivers of ice that dump ice into the ocean, it started to become clear oceans could actually play a role in controlling those glaciers. And so Oceans Melting Greenland, or OMG for short, was born as a way to try and answer the question, how much are the oceans controlling the glaciers? How much are they causing them to dump extra ice? And what does this mean for the future of the ice sheet? Greenland has enough ice to raise sea levels by 25 feet if it all melted today. The ice sheet is 10,000 feet tall in the middle, and you fly over it in a jet for 2 hours and you're still on top of it. So it's an enormous chunk of ice and something that is a big part of our climate system.
So by 8 o'clock we'll figure out if we're going to go north. If we don't go north today, then we have to hit it hard Wednesday to go north and then leave for Thule on Thursday because the weather is not looking good.
It's always an adventure doing work in Greenland, and it never works out exactly like you planned it. You really have to pick your places very carefully where you're going to be able to land, stay a couple of nights, get fuel for the airplane. And of course, the schedule almost immediately gets thrown out the window because the weather's bad, or one of 100 other things could go wrong. And the last 2 years, we also had to deal with COVID. It was just one more of 100 other challenges of getting this crew and this airplane to measure the ocean temperatures really all along Greenland's coastline once a year for 6 years. We started with a ship. The ship drove around the edges of Greenland and mapped the sea floor. The water there, remember, is upside down. You've got the cold water at the top and the warm water down below. So if the warm water is going to reach the glaciers and interact with them, the glaciers have to be sitting in warm water, and there has to be some deep water that connects the glacier with the water offshore. So the first couple of years, we really just mapped the seafloor, and we revolutionized our knowledge of the seafloor depth around the island. Huge areas had just never been mapped, and we had no idea how deep they were. So with the data collected by OMG, we now know not just which glaciers are reacting to the ocean, but why they're reacting. And it's almost always because they're sitting in deep water and there's a deep channel connecting them to the offshore. When we were flying around measuring the oceans, you drop this cylinder out of the airplane. It falls on a little parachute, and when it hits the water, it separates into two parts, and one part stays at the surface and it radios data back to the plane, and another part sinks, and we get one profile of the temperature and the saltiness of the ocean from the surface all the way down to the seafloor, because we really want to know what that deep water is doing, because that's the water that melts the glaciers. We drop those things about 200 times a year, covering the entire area around Greenland, so we have a snapshot of what the oceans look like. What we've shown during the course of OMG is that the glaciers are paying a lot of attention to the oceans. These are magnificent, enormous rivers of ice that empty into the seawater, but they're not disconnected from what's happening in the oceans. When the oceans warm, they retreat more quickly. When they cool, sometimes they even grow. And these glaciers are often sitting in a lot deeper water than we've realized previously. And that means they're a lot more threatened by the water. And Greenland has the potential to raise sea levels much higher than we previously knew. So basically every time we made a big discovery on OMG, we had to raise the bar on our predictions of sea level rise from Greenland. Without the ocean's role in melting away the ice, you're only getting half the story. I started working on OMG in 2012, almost 10 years of my life, and I've definitely grown as a scientist. I started with one idea of Greenland as a pretty simple block of ice. Of course, it's fantastically complicated and interesting. You see these sharp mountain ridges where the ice has just cut a channel right through it. There's giant icebergs. The glaciers are literally moving, so you can't see them with your naked eye, but if you go back from one year to the next, you can see how they've changed. It's really a dynamic place, and that's part of the reason it's so scientifically interesting, but of course, it's just beautiful to look at too. If you talk to Greenlandic folks who have been living near these glaciers and whose families have been watching these glaciers for generations, they know that the glaciers are shrinking. We found that they wanted to know about the science and what we were finding almost as much as we did. They're living in a landscape that's changing probably more dramatically than anywhere else on Earth. This is an important place. It's important for the entire world. As ice is lost in Greenland, sea level goes up everywhere. It's literally all around the planet is affected by what happens in Greenland, and so it's going to shape a lot of our future too, not just the Greenlandic folks.